Good afternoon to you. Mark Sudduth, HurricaneTrack.com, here with your hurricane outlook and discussion. It is now Tuesday, July 28th, 2020, and we have a big story developing now. Potential tropical cyclone 9 on its way to becoming a tropical storm, and we will deal with how to pronounce it later. I have to practice it for a while so I don't butcher it. We will just call it the I storm, and it's coming. This is what the National Hurricane Center has as of 11 a.m. Eastern Time. What is all of this PTC all about? You know, maybe some people aren't familiar with this. Well, in the last couple of years or so, the National Hurricane Center started issuing these potential tropical cyclone advisories for a system close enough to land that as it develops, you might want to get watches and warnings going because it's probably going to develop. And at least those watches and warnings are up, and it allows different mechanisms to be in place, especially when model guidance is in favor of development. It just makes things a little bit easier. I know it's an extra term to have to deal with, but that's what that means. Potential tropical cyclone, and this is number 9 of the season. You know, we're going down the list of depressions and named storms or whatever. This isn't quite a depression, but it's a potential tropical cyclone. And we're basically up to the 9th occurrence of something trying to form of the year. Does that make sense? And of course, as this gets going, it'll be, what do we got? A, B, C, D, E, F, G, H, I. This will be the 9th named storm. And my printer's trying to print. So you understand how that works? Somebody's printing something in my office. I don't know who. Number 9, because it'll be the 9th named storm. Anyhow, let's take a look at the track for it. This is from our tracking map that we're working on. All kinds of good things we're working on behind the scenes. The next several days, this is the plot for it, coming across the islands here, as you can see. And yeah, this is going to cause problems. It's going to have impacts. And, you know, just because it's not a hurricane doesn't mean you don't take it seriously. This whole area through here, as it chugs through, depending on exactly where it heads, you know, from Guadeloupe over here through Antigua and Barbuda, U.S. British Virgin Islands, on over to Puerto Rico, maybe eastern parts of Hispaniola. Heavy rain, squalls, you know, the wind to tropical storm force, maybe higher. Maybe, you never know. You can get hurricane force wind gusts, and that can cause damage. So look at this from an impact perspective. Hey, something's out there. It's going to impact my area probably. What are those impacts going to be, and how do I deal with them? Everybody's different. Everybody, you know, if you live next to one of those guts, as it's called, those little, I call them a wash or a gully. Out west, they're called arroyos. You know, that could fill up with water. That's one thing to be concerned with. If you live on a hillside and you've got a beautiful view of the Caribbean, well, you're also exposed to higher wind. And everybody is different in terms of their particular risk, but this is coming. You know, one way or the other, this is heading in your direction. The islands of the Northeast Caribbean first, then eventually the Bahamas here, and maybe South Florida. We will just have to see. This is a 5-day forecast. We'll just have to see what happens with this. This is the very first advisory, and so you know how this goes. We have a long way. Let's see what this update is. Okay, it's just a correction. Just making sure that something didn't change while I'm talking. So watches and warnings, a tropical storm warning in effect for all of these areas right here. That covers a lot of those islands of the Northeast Caribbean. And then in terms of the hazards affecting land, this is what I like to focus on the most. And, you know, wind right now, rainfall, 3 to 6 inches of rain. Yes, you need the fresh water. But that can cause problems if it's coming fast and furious. So please take this all very seriously, okay? We're not hyping it up. It is what it is. And even potential tropical cyclones can cause problems, especially if you are caught unaware and don't really know what's happening with it and don't respect the power of these big weather systems. They're bigger than you and me. And that's what you got to always remember. You know, all the weather, every single weather phenomenon is bigger than you and me. And therefore, it can impact you. Hey, look at the vorticity signature. This is from earlier today. This is the 0600 UTC. That's 2 a.m. Eastern Time. And this is what it looks like more recently. And you can see there, as I totally screwed that up, How do I fix this back? Well, I can't. That's fine. As you see there, it's really improved since then. All right, so there's the 0600 UTC, and let's just refresh it. That's how I'll fix that. I don't know what I did. That's fine. Now the vorticity signature is still kind of oblong, yes, but it is definitely trying to focus. And let me draw on here with the color white. More in this area right through here, it looks like. And that's where the hurricane hunters are flying. They're out there checking out what's going on. We'll know a lot more about this over the coming hours. And looking at the satellite picture, this is a satellite picture, but it's a different perspective, so to speak. This is clouds. This is the spin in those clouds, or the vorticity. Does that make sense? So here's our system right here. Large envelope of energy associated with it. I'm telling you something. If this can focus that energy and sort of shed this one area right here away. Remember Matthew had that. Some like tag-along system was with it, a big area of convection, and that competes for energy. Once Matthew shed that back in 2016, it really intensified and became a Category 5. If this system here, PTC9, almost Tropical Storm I, is able to bundle that energy and sort of shed that other system, it could start ramping up very quickly. And I believe maybe, and I could be reaching here, I'm just trying to speculate and understand why it's not ramping up faster. But I think one of the overall sort of issues with it, if you have to look at it from that way, from the performance perspective of how this thing's behaving, the very large size of this envelope of energy is one of the reasons that perhaps the global models are having a difficult time understanding what to do with this from a numeric and a physical perspective. This is a giant piece of energy. Look at the influence with the whole area. That's enormous. If you move that into the Gulf, it would take up practically the whole Gulf. I mean, my circle in the Gulf's smaller. I mean, really. And then look, to the east, there's another system. That'll be interesting to see if that gets outlooked. And there's even more back over here, over Africa, in the days and weeks to come. I mean, holy cow, it's going to be a very busy time. We knew this was probably going to come, and here it is. So here's a visible satellite animation courtesy of the weathernerds.org site. And here's what I'm talking about. A very large area of overall energy associated with this system. This area of convergence and thunderstorm activity trying to suck in air. You can clearly see that. And that's not the scientific way to put it, suck in air. You know what I mean? The inflow, that's a better way to describe it. The air is trying to move in, but it's also trying to do it over here. And there's maybe more of a mid-level rotation going on over here. And also at the surface, this is where it looks like it's trying to come together. East of Barbados right there. And, for what it's worth, more lightning over here than we're seeing over here. So I believe that this western lobe, as I've seen people call it, may be trying to take over. And if it can do so, and this will die off, this could really start to ramp up quickly as it comes across the islands. And I'm telling you something too here based on experience, not just from being in over 25 of these things on purpose, but also seeing what they do and hearing from other people over my 25-year career that have gone through these when they are strengthening. Even a tropical storm that's on its way up in intensification, those effects are more pronounced because those updrafts in the thunderstorms help to bring down those winds to the surface much more efficiently. The heavy rain inside those updrafts, those thunderstorms that you get, that deep convection. So if this is intensifying as it goes over your location, your wind gusts probably will be higher. You'll notice it more than a system that's just kind of lollygagging along, and certainly versus one that's weakening. Now, an intense hurricane like Irma or Maria, where it hits you at peak intensity, like Michael, I saw that firsthand, that's different. It's bad for everybody in that core. But in this situation, as it's coming together, you feel that fury of the intensification process as it goes over the top of you. I've seen it firsthand, and it's something to be aware of, especially in some of these islands down here where you do have elevation. Those wind gusts could exceed hurricane force. Wouldn't surprise me at all. All right, looking at the potential for this, I mean, the upper ocean heat content is absolutely all green across the board for this to develop all along this path through here. Very high upper ocean heat content, no doubt about it. That means that the water is warm not only at the surface, but also several tens to maybe hundreds of meters deep, just depending. And that's what that is. The upper part of the ocean is warm down at depth, not just at the surface. And it's absolutely remarkable how warm that is all the way up off the eastern coast of the United States. Wow. I mean, we are really going to be in for it if the hurricanes come. So here's a close-up of this area. The system, the eye storm, is going to be moving through here. And I don't mean to joke about it. I will work on my pronunciation because I'm a stickler for it. It's not Isaias. I'm going to tell you that right now. It's not. I mean, you can say it like that all you like, but it's not. It's more like Isaias or something. Isaias or whatever. I said I wasn't going to try, but it's not I. It's E. Isaias or whatever. Isaias. The first part's an E, not an I, how you pronounce it. But anyway, it's going to come through here. Very high octane water to work with, no doubt about it. And so that being said, let's look at the GFS, shall we? Now, I'm showing you a different perspective here. I usually use the Tropical Tidbits site, but I wanted to just go back to my old throwback days of the INCEP site, where the GFS originates, and just use it, something different, just changing it up a little bit. It's still the Western Atlantic, and we're still looking at the 850 millibar level of the atmosphere. We'll use red for this to pop. Here's the east coast of the U.S. right over here, and we'll just stop with Florida there. Here are your islands of the Lesser Antilles, right? There's Puerto Rico right there. Bermuda, for reference, is right here, and the islands of the Bahamas through here. And what we're looking at is the 850 millibar level of the atmosphere. It's like the atmosphere is layered. Like a cake, like onions, like Shrek and Donkey, remember? Right? Onions have layers, so does the atmosphere. And about 5,000 feet up, that's where I like to look. That's my favorite area to look. And if the system is well developed there, then it can be well developed all the way to the top. If it's not looking good at the 5,000 foot level or 850 millibars, if that structure is not intact, to me, nothing else matters in the long run. That's why I like this layer of the atmosphere the most. It doesn't mean that I'm right. It just means that's what I like to do. So let's put this into motion, and we'll see what happens. And the nice thing, I like this, how it loops, etc. You see it coming in there from the right, from stage right, and it goes right through the islands, over Puerto Rico. We're going to slow this down and see what happens with it. Comes in through there, and let's stop it right there. So right there on top of the Virgin Islands and over Puerto Rico is where it seems to start to ramp up. We can go back and forth a little bit there. Kind of discombobulated through the easternmost islands, but then as it approaches Puerto Rico, U.S. Virgin Islands, that's when it seems to try to get together. So you guys down there in that area, really pay attention to this. Puerto Rico, flooding rains, big problem. And I'm going to talk about some of these impacts more in just a minute and how we're going to be able to show those to you. Beyond Puerto Rico, and there's lots of wind flags in there, those little triangular looking things right in here. In fact, I do believe this will allow me to zoom in. Yeah, it does. How about that? Very nice. These little triangles, those are 50 knots. So this will be blowing pretty good. This is 5,000 feet, not at the surface, but that's getting it, that's for sure. And then this goes on into the Bahamas. But then curiously, you see the structure of it kind of right? And where are we out? 114, 120. There we go. 5 days. It's reduced to 2 shades of green. You see that? Not very impressive in the model. Why? Why is that the case? Well, there's the first image. There's the last. Now, let's move up in the atmosphere to the 200 millibar level. This is higher up, about, 35, 40,000 feet up, what we call the outflow level. So you want the atmosphere to be stacked vertically where the wind is all going in the same direction. And at the upper part of the atmosphere, everything's fanning out clockwise. That's how you get these things to intensify. It's interesting. Let's compare these. There's 5,000 feet, 850 millibars, 200 millibars. Our system is located right in there. I can't explain why it's not stronger. It's sitting on the northwest side of this massive anticyclone right there. I mean, are my eyes, it's clockwise, right? I'm trying to figure out. And it's sitting over, if we look back at the ocean heat content, very, very high heat content in the Bahamas, right off the Florida coast. So I don't understand. If there's some dry air, this is a trough coming through here, so there is shear, but that's up over this way. I don't know. I can't explain it. And we'll just have to see. This is 5 days away. I will tell you this, though. If the anticyclone co-locates with it, and it's more right underneath like that, underneath that anticyclone, perfectly centered, where the air is fanning out in all directions evenly, look out. It could be very intense heading into Florida through the Bahamas. I just don't know. I don't know if it's if there's something going on in the models, if it's the system itself, that is too large. I don't know. Maybe it's the lack of airplane data because of the pandemic and the lower amounts of air traffic that we're providing some additional, many times, thousands of additional points of data. I don't have an explanation. But I'm going to tell you, let's try to look into that explanation when I do my next video later today. Around 4:30 Eastern Time, I'm going to have another video discussion, and this time it's going to look a little different. I'm going to have Jack Sillen from the weathermodels.com site, weather.us. He's going to join me. We're going to record it. I'm not going to do it live because I want it to be perfect. And my bandwidth here, I'm a little worried. It's another pandemic problem. Everybody is at home using the bandwidth. They're all playing Call of Duty and Fortnite, I guess. I'm trying to work. So they're sucking up all the bandwidth. I'm probably right about that. I know I'm right about me working. I don't play the games, not until the off season. This is very serious. So Jack and I'm gonna record his discussion with me, and we're gonna talk about intensity a little bit. See what he sees. All right? I think you're gonna really, really like that. And I've had Jack on before with the Hurricane U series that we've been doing, and you're gonna really, really enjoy his insight. Also, we will have live cameras down in the area. Already got them. Our Patreon support is more than just the funding. We have people, it's a community. They help with the funding. Yes, money's what makes the world go round. But some of our people down there in the Virgin Islands, Timothy and Brent and Carlos over in Puerto Rico, they have cameras that were purchased with our funding. And 2 of those cameras run 24/7. St. John and St. Thomas. That would be Brent and Timothy respectively. Carlos has one of the unmanned cameras, one of my boxes, that we left down there after Dorian. He's going to activate it and set it up this evening from San Juan. So we're going to be able to show you exactly what's happening. That'll go first to our patrons. Then we will set up something on YouTube so you can watch it there. Got to figure out a way to fund this, of course, so we try to give something back to our supporters for the crowdfunding effort that they provide. But the bottom line is we want to do the best we can for the public and the greater good, and so we all have to work on that balance together. But I will be bringing you some live coverage from the area as soon as tomorrow. All right? So we'll talk about it again in a few hours. We will take a look, Jack and I, at the European model, the ECMWF, as well as the Ensemble Prediction System, the EPS. You'll see. I'll let Jack explain it. He can do a better job than me. And this is what I like about social media. I don't know everything. I bring in other people to help me shape what we're looking at. And again, I think you're going to really appreciate what we're doing here. And I can't wait to talk to Jack in a few hours. All right, don't forget I'm on Twitter at HurricaneTrack, YouTube.com/HurricaneTrack. And as I mentioned, join the modern era, and it really is the modern era of hurricane coverage, other weather coverage. We're building it. That is on Patreon, patreon.com/HurricaneTrack. Check it out. I am Mark Sutta. Thanks as always for tuning in. I'll be back in just a few hours with a lot more.